Hi everyone, this video is going to give you a quick review for those of you who said you needed some help with depolarization and repolarization. So we were talking about it in context of the heart and the electrical conduction pathway through the heart, but I'm just going to do a general review so that everybody understands what depolarization and repolarization means. And to do that, I'm going to just borrow the nervous system for a minute to talk about it. So we're going to talk really general. Okay, here's a cell. Okay, you have two environments. You have your intracellular fluid environment and you have an extracellular fluid environment, right? So we have fluid inside the cell, we have fluid outside our cells, but these environments are not equal to each other. Okay? They're not the same. When we were talking about neurons back in the nervous system, we talked about a charge difference between the intracellular fluid and the extracellular fluid. So way back in AMP1 when you discussed ions, right? Remember, an ion is a charged particle. We only have two choices for charge. It's either a positive charge or it's a negative charge. If there's no charge, it's simply neutral, okay? When you put these charged particles in fluids, there's going to be a charge that's associated with these fluids. So, when we were talking about neurons, we said that the inside of the cell was at a negative charge comparable to the outside of the cell. So the inside of the cell was negative relative to the outside, okay? So what does this tell us? Because there's a difference in charge across the membrane, we say that the membrane is polarized. So we think about when people are polarized on a given topic, it means that they are at opposing viewpoints. So think about the charges being opposed to each other. One is negative relative to the other, which is more positive, okay? Hopefully that makes sense so far. So when a cell is stimulated, we are going to depolarize it. We're going to remove the charge difference across the membrane, okay? But when a neuron, for example, is at rest, it's polarized. This is called its resting state. We remember that negative 70 millivolts was its resting membrane potential. And we can tap this potential energy to do something. Okay, so when we depolarize, we're going to back up for a minute and talk about I won't even erase yet. We're going to back up for a minute and talk about two ions. You've got sodium and we've got potassium, okay? To maintain our resting membrane potential, which is negative 70 millivolts, and all that really tells us, okay, a volt is a measure of charge, just like a 9-volt battery. Millivolts tells us it's 1/1000th of a volt, and this negative is just telling us that it's a negative charge inside the cell, right? So we have two ions that we want to talk about, sodium and potassium, okay? When a cell is at rest, the resting membrane potential has to be maintained, and it's maintained by the sodium-potassium pump. Okay, so what that is doing, anytime you see a pump, we think ATP, right? That it requires some energy in order for that to occur. And what this pump is doing is maintaining this negative state inside the cell versus the outside of the cell. So then the question is, how is it doing that? Well, these are both positive ions, right? So we need to pump one out and the other in, but we're not going to do it at the same ratio. Cells, many cells, are leaky to certain things, so things really want to flow back and forth and achieve equilibrium, but we don't want that to happen. So we need to turn on this pumping system to maintain this negative 70 millivolt state inside our cell. What we are going to do is pump out sodium and pump in potassium, but not in equal amounts. right? We can pump 3 of these out for every 2 of these in, and eventually you're going to have a negative state inside the cell because you're pulling out more positive out of the cell than you're putting positive into the cell. So hopefully that makes sense, okay? All right, so what happens when we depolarize? We remember back when we learned, okay, and I'm just going to kind of leave this over here. Remember back when we learned about cells, certain things could pass through the membrane really, really easily, but other things could not and needed a channel. So now we're going to install 2 little channels. One is going to be for sodium and one is going to be for potassium. So just envision them like little openings, okay, that things can pass through. In this case, we're going to be very specific. 1 ion can pass through one of these channels and 1 ion can pass through the other channel, okay? So let's say for argument's sake, the green will be our sodium channel and the red will be our potassium channel, okay? When the cell is at rest, you want these channels completely shut, closed, and the sodium-potassium pump is maintaining, okay, there we go. So at rest, you want the channels closed because the pump is doing its job, right? The sodium-potassium pump is turned on and is maintaining negative 70 millivolts inside the cell, okay? So at rest, we got both channels, both the green and the red, snap shut. That's the idea. And then we would turn on the sodium-potassium pump. And it's going to pump sodium out, and it's going to pump potassium in, okay? When a cell is stimulated, so let's just say, here we are at rest, okay? So here we are at negative 70 millivolts. Sodium-potassium pump is on. Let's say the cell or neuron becomes stimulated. If it's stimulated above a certain threshold, which is about negative 55 millivolts, we will generate an action potential. Okay, so we got the pump turned on. It's pumping the sodium and potassium in opposite directions. Okay, we're going to stimulate this cell, and we're going to stimulate it above threshold. What will happen when the cell is stimulated above threshold is we will open sodium channels. Now remember, we were pumping all that sodium out, so the concentration of sodium is high out here and lower in here. If I open the sodium channel, sodium is going to flood from high concentration to low concentration and run into the cell, okay? That's going to take the inside of our cell from a negative state, because you're adding positive ions, to a positive state. Now, both sides of the membrane are positive. You are depolarized. Okay? So that's depolarization. So we're depolarizing. You're taking your inside of your cell by adding lots and lots of sodium ions, which are positively charged, into the center of our cell. You're going to take the inside part of your cell from a negative state to a positive state. We have depolarized across the membrane, okay? And we've generated an action potential. But you can't leave the cell constantly stimulated, because it would be like a nerve constantly stimulating a muscle and never letting it relax. So now we want to go back to rest. So we have to do repolarization. So on this side, we will close sodium channels. We're done with those. But we're going to spring open the potassium channels. And remember, we had been pumping potassium into the cell. So potassium is at a higher concentration in here than it is out here. So when we open up those channels, potassium is going to leak out through its channel, because it would like to achieve equilibrium. If you do that, you're losing all these positive ions out of the intracellular space. So that's going to take our cell from a positive charge inside the cell back towards our negative charge. Then eventually, the sodium-potassium pump will turn on, and by doing that, you're going to come back to rest, and you can do it all over again. Okay? So when we depolarize, we're going to open our sodium channels. On this side, potassium is shut. They're closed. So potassium is not moving, but sodium is. When we depolarize, we're going to pop open that sodium channel. We have a lot of sodium out here, very little in here. It's going to flood into the inside of our cell, taking the inside of our cell from a negative state to a positive state. And that's an action potential. The action potential is an electrical impulse, right? So it's the same thing that's going to happen in the heart. But we don't want to leave it like that because you'd be stimulating the heart to contract but never letting it relax. So we need to go back to rest. So on this side, we are going to, I'm going to keep it consistent. On this side, we're going to repolarize. Because you're going to go back to a resting state. So to achieve that, we've got to cut off that flow of sodium. So we close our sodium channels. We're going to open up potassium channels. Now, because potassium was at a much higher level out in here, because remember we were pumping it in, than it is at the outside of the cell. As soon as you open this channel, that ion is going to want to achieve equilibrium. So now potassium is going to leave the cell, and because you're pulling positive ions out of here, the cell is going to become increasingly more negative in the interior space. The sodium-potassium pump will then turn back on, and we'll start pumping sodium out and potassium in, and reestablish that negative 70 resting membrane potential, and you can stimulate it all over again. I hope that helped.